Full Metal Brotherhood. That's a different one.
Just start with that one.
All right. We gotta shift. So I had a lot of good questions in office hours. Does anyone else have any other questions? Because did you notice two things? Let me show you two things. Dadgummit. If it will let me show you. Here we go. So two things. One thing is we have a quiz on Monday, right? Chapter 6 and 7. So what I did was I put up in Unit 7 practice quiz 5. That is practice from chapter 6 and 7. All right. You know what? I think this is more just chapter 7. Yeah, well, that's all right. I mean, chapter 7 is chapter 6, basically. That'll be okay for her. That'll be good enough. Why does it say quiz 5 too? I don't know. Anyway, so that's up there. That's up there. Any questions from chapter 7 homework? There were, like I said, there were some really good questions during office hours.
Are you still gonna like teach us like a few things from chapter 7 like today or no? Because like when I was looking at the homework assignments, it talked about like interquartiles and like the first, second, and third quartile. Like, are you gonna do some examples of that today in class, or are you gonna?
I mean, we could review those because, of course, we've talked about those before. So those are old ideas, right? I mean, what's a quartile mean? What's the first quartile?
Well, I know that like the 25, 50, 75.
Okay.
But the thing that stood out to me was the interquartile.
Sure.
That kind
And
of
that's
confused
just
me.
Q3 minus Q1. That's all it is.
Oh, okay.
Yeah, and I think that came up in at least one homework problem before, if not a couple, back when we talked about percentiles and stuff. You're
Thank you.
welcome. So yeah, feel free if there's anything in the homework problems, because they like to bring back stuff from before, which I love, to try to keep it fresh in your brain. But of course, you can always ask if you're like, "What the hell's this?" Just ask, no big deal. But I mean, if there's no specific questions from chapter 7, we're actually going to get right into chapter 8. Okay. All right. No questions. Okay. So we're going to get into chapter 8. We're all crazy. Here we go. So we're going to kind of sneak into chapter 8 a little bit. We're going to ease our way into chapter 8. So let me see. Get you out of here. So the thing that, well, all right, chapter 8 is a funky thing to talk about, but it's something that we see all the time. So what I'm going to do, we're going to actually learn chapter 8 stuff, and then I'm going to show you how it shows up in statistical analysis. We're actually going to look up some statistical analysis on the internets and see if we can see anything that looks familiar to us. So let me ask you, let's do a couple things. Let's remember what central limit theorem says. So sort of a little bit of a chapter 7 review. All right. So what does the central limit theorem say? Sorry, try to jerry rig something here to make this work better. All right, let's see. It's gonna bug me. All right, why does it look so bright? Central limit theorem? Anybody remember anything about central limit theorem?
That if n is higher than 30,
I like it.
then the sample is normal.
If n greater than 30, then the sample means are normally distributed enough. They're close enough to being normally distributed. I like it. That's one thing it says. Oh, Corbin's got the second thing. Be more specific, though. So I like it. As n increases, the standard deviation of the means decreases, but we know exactly by how much. What is the new standard deviation? How does it relate to the old standard deviation? What's that formula? Okay.
Square root of x.
Yeah, okay. I like it. So you can see as n gets bigger, the spread gets smaller because I'm dividing by square root of it. Okay. All right. And the last thing it says, this is sort of in opposite order, but oh well. The mean of all the sample means is the same thing as the original mean. So that does not change. Okay. So that's basically what chapter 7 was all about, was we deal with samples normally in statistics. So what happens when we take a sample? How does that change things? Because chapter 6 was all about taking one thing at a time. Chapter 7 is like, let's do all that shit again, but let's take like 16 at a time this time, or 57 or whatever. All right, maybe. So I'm going to erase all this. So this is central limit theorem. All right, so let me erase all this. I'm going to put the important stuff up in the corner. All right. All right. Now, I'm going to kind of try to build the parts we have to know to be able to do chapter 7's math. I'm sorry, chapter 8. We're getting into chapter 8. In chapter 8, you can see the title of it is called Confidence Intervals. It's a very strange phrase, right? So let me ask you, let's kind of build our way up to this. If I had a normal distribution, can somebody tell me what would the z-scores be that go with this picture I'm drawing right now? So the middle 90%. So what two z-scores capture the middle 90%? How in all of hell would I figure that out? What do I have? What am I going to reference? What do I need to use to figure that? Even if you don't know how the hell we're going to do it, what do I have to use?
Chart.
Say again, sorry?
The z-score chart.
Z-score chart. I love it. We have to use the z-score chart. What's the only kind of area that the z-score chart understands?
In between 0 to 1.0.
I'm not sure what you said, but Corbin's got it. It only understands areas below the z-score, area to the left, correct? You guys with me? So would the chart have any clue what to do with this 90%? Would I look up 0.9 on the chart? Would it understand what that means? What this area here means? No, because it only understands areas below. So how would I figure out this z-score right here? Let me call it negative z, and I'll call this z. How do I figure out him? What do I need to know to figure out him from the z-score chart? What do I need to know? What's the only thing the z-score chart understands in terms of area? It only understands area that is below a z-score. I love it. What area is below that lower z-score? What area is this?
Would it be 0.05?
Beautiful. Of course it is. Right? If there's 90% in there, there's 10% outside, so there's 5% on that side. All right, so this is an old question. Go do this right now. What is that z-score? Don't say anything yet. Don't type anything yet. Just go find it and sit on it. So find what that z-score is. You guys looking it up? Did anybody find it yet? You can tell me now. Anybody?
Would it be 0.4801? Because I'm looking at the negative one.
0.05, is that a z-score or is that an area?
Negative 2.575.
No, I think you looked up 0.005. In fact, I know you did.
Yep, yeah, I did.
So let's all do this together. All right.
Is it negative 3.30?
No. Now you guys are all like, I don't know.
Negative 1.645.
Yes. So let's take a look here. Let me pull up the z-score chart. There it is. Share it. There we go. So I'm looking for an area. So I know I'm going to look in the body of the chart because that is an area, not a z-score. So I got to find the closest I can get to 0.05. And it's in between these two. Do you see that? It's in between negative 1.64 and negative 1.65. So look what they've done for us. Look, if you follow the little trail, yeehaw, I get down and they tell me they just split the difference. Does that make sense? If it's directly between 1.64 and 1.65, then it's 1.645. You guys, is that cool? Do you guys see where that came from? Okay. Or not cool, but at least understood. All right. Is that all right? You guys all right? So can somebody tell me without doing any work what this one is?
Positive?
Yeah, because it's got to be symmetric. It's the middle 90%. These are going to be symmetric. So this has got to be 1.645, positive. Now. Let me push this a little further. What if I have, so I have a normal distribution. Let me add some information on top. Let's say that I know the mean of this distribution. Yeah, let's go ahead and say it's the heights of American men. So the average height of American men is 69 inches tall. Standard deviation is 2.8. Can you please figure out what these two z-scores, what heights they correspond to? Can you convert these back into heights? Right, so this would be a height of 69. I'm curious, okay, what height is this and what height is this? What heights do those correspond to? How do I do that? How the hell do I do that? And you're all like, if you don't know, we're screwed, Jeff. I know how to do it. Anybody? If I know a z-score, how do I convert it back to x?
That'd be the mean plus the standard deviation multiplied by z-score.
Yeah. I really want you guys. What the hell does a z-score tell you? Somebody else tell me. Who knows what a z-score tells you? What does a z-score tell you?
The amount of standard deviations a value is from the mean.
Exactly. So if I know the value has a z-score of 1.645, that means it is 1.645 of these above the mean. Isn't that this formula? X equals the mean plus z sigma. This, have I pointed this out to you guys before? This formula, are you allowed to have notes when you go take a midterm or a final or a quiz? Are you allowed to use your notes? Hell no. But I do give you formulas, don't I? This is a formula that happens to also be a note. This tells you the definition of z-score. The z-score is the number of standard deviations away from the mean to the data point. Holy shit. Right? So I have to let you have that note because it's a formula. Too bad for me. Right? No notes except for the formulas that are notes. All right. I don't know if you guys are with me at all or not. So it just makes sense to do this. If I know it's 1.645 steps up from 69, then I take 1.645 of these from 69. What do you guys get for this? Anybody doing that for me? Anybody? Oh, there we go. Somebody's doing it for me. So 73.606. We'll do that in 64.4. Is that what other people are getting?
Yeah, that's what I got.
So tell me this. Sorry, riddle me this stuff. Tell me this. If I went out and I collected, somehow I have this ability. I go out and I get every man in America who is between 64.4 and 73.6 inches tall. You guys with me? I put them all in, I have no idea. A giant paddy wagon, right? That's an old term. I put them all in this container, right? All these men. What is the probability that I got a certain man? So there's, I want, what's the probability that I got Fred, I keep thinking Durst, but no, Fred Fontana Jr., right? This certain person. So if I get every man that is between 64.4 and 73.6 inches tall, what is the probability that I got this particular dude? You could do it. What's the probability that I got this specific dude if I get all the men between those heights? I love you guys. You're all like, what is this guy on? I see the right answer in the chat. I see it. 90%, right? What percentage of men are between these two heights? 90% of men. So what's the probability if I go collect all those men that I got a specific man? A 90% chance. Yes. If 11% of you are left-handed and I pick a student, what's the probability that student is left-handed? 11% chance. What's the probability that I pick a left-handed student? 11% chance, right? So if I get 90% of the men, there's a 90% chance that I got a specific man. All right. I know this sounds really strange, but does it make physical sense? Does it make sense? No. Kind of makes sense. I mean, if If I caught 80% of the fish in a lake, what's the probability that I caught a specific fish?
80%.
80% chance. Okay. All right. This must be central to this idea, or else I wouldn't be spending so much time on this thing, or I've gone insane. That's always a possibility. All right. So I'm going to erase all this. Now, here's what we're doing. Up till now, we've been given a mean and a standard deviation of a population. Would you agree? Chapter 6, chapter 7. Everybody agree with me? Because if you're not given one of those things, how the hell are you going to do anything, right? When I go to investigate some situation, will I always know those two things?
No.
No. So, like, for example, if there's a, well, I don't want to talk about, let's not talk about that. I don't know. If there's a brand new drug, do I know the average length of time the drug is going to take effect in people? No, I don't know that. I have to go take a sample and figure it out, right? Okay, so that's what we're finally getting into. We're finally getting into more real world stuff. Believe it or not, we haven't been there yet until now. So normally I don't know either one of these two, but we're going to start off easy. We're going to start off nice. We're going to say, okay, let's say I do know this, but I don't know this, right? Now, what situation would be like that? Stay with me now, guys. By the way, this happened last time. So we're going to talk about concept, and then we're going to get the formula, and then we're going to do a concrete example, right? So do not freak out about all the shit I go through, because you're not going to have to go through all that shit yourself, okay? But this situation is one that could happen. So let's say, for example, all right, I can't get that out of my head now. That sucks. Come up with something better, Jeff. There, okay. Let's say that we know SAT tests. And we know that the standard deviation of all SAT tests scores. Standard deviation is like 350 or something, let's say. Right? And let's say that I take a sample. So so stay with me. We just know this. How do we know this? Because we have all the data for all the frickin' SAT tests, correct? We just know it. Some of you guys are going to say, we also know the mean, Jeff. Yes, but watch what I'm going to do. I go to a specific region and a state, and I take a sample. So I go to a state. Let's say I go to, it doesn't matter, Jeff. I can't get Kentucky out of my brain for some reason. So I go to Kentucky, and I go to a little piece of Kentucky, and I take a sample of, let's say 42 kids from this little area in Kentucky, right? And what I want to know is, what is the average SAT score for that little area? So I want to know mu for this little area. All right, so this is not the best example in the world, but we'll deal with it. Okay, so all right, this is, again, maybe it would have been better to do the first thing, but I'm not gonna. So for some reason, it's a little bit bigger of an area than I thought. And so I don't have all the time in the world to talk to all the kids. I don't have all the time to go get all their scores. So I just take 42 kids. I can calculate a sample mean. Are you guys with me? If I take the 42 kids, I can give them the SAT test and I can calculate a sample mean, correct? Yes, but I'm not going to know the population mean, right? I'm not going to know what the population mean is because I don't have time to see the whole population. Is everybody with me out there? Okay, I like it. I like it. So I can find X bar, but what I want is mu, right? But I don't have time to talk to everybody. So this is finally the connection of statistics between when I take a sample, but I want to say something about the entire population. We're getting into that math now. So what we're going to do is this. How do I want to say this? I can do this much. All right, here's what we do. If I wanted to be 90% confident about where mu is, all right, I don't know a better way to say that. All right, just stay with me for a minute. Right? I kind of want to do what we just did a minute ago. I kind of want to make an interval between which I catch 90% of the data, like we did with the heights, right? If I catch 90% of the data, how confident am I that I caught anything specific, like the real mean? I would be 90% confident that I caught it. Stay with me. This is until we get it all out there. So let me see. I need some more space. That's too bad. So if I start with this, let me just write that piece down. Let me start with this. I don't know mu, correct? That's the whole problem with this. I don't know mu. I kind of want to know it. I want to get a feel for it, but all I'm going to be able to get is this. So I don't have mu. I have to replace it with X bar. Now. If I take a sample, what changes? If I take a sample, and I'm talking about the sample means, what changes?
The deviation.
Standard deviation. So this is no longer that, it is now this. And then I've got my z-score sitting here. And to be 90% confident, I want to go up and down a certain number of steps, just like we did with the heights earlier. You with me? So if I go up and down a certain amount, in fact, how many steps to get 90%? 1.645. We already know that, don't we? From the example we did earlier about the heights. All right, so let's do this problem. And then I've got a handout to show you. Let me see, I need, all right, let me write down what I need. I need sigma is 350. Did we figure out what X bar was? Let's say, oh yeah, I got to make up an X bar. So we give these kids, how many kids did I take? 42 kids. All right, that doesn't sound creepy at all, Jeff. I give them all the SAT, and let's say that their average SATs, what the hell is the SAT test nowadays? Let's say they get 980. Does that sound reasonable? I have no idea what the SAT is like anymore.
I think the highest score is 1600.
Okay, that's what I thought maybe. So let's say they get a 980, right? All right, so I basically took that information and put it down there. So is this the actual mean for all the students, all the kids in that area? Is that the actual mean? Oh, sorry.
No.
Hell no, right? It's just for my sample, correct? But
Yes.
if I picked a good random sample, this mean should be close to the real mean. Okay, I like it. Stay with me. So now if I do this, this is kind of nifty. I know this is wrong. is more than likely wrong. It's just my sample, not the whole population. So if I go up and down this many steps, I will be 90% confident that that interval catches the real mean. Because how confident am I that the interval catches any specific thing? 90%. So how confident will I be that it catches the real mean? 90% confident. So let's see what we get when we plug stuff in. 980, give or take. And is everybody cool? Remember we just did it a minute ago? 1.645, right? Up and down to catch 90%. What was the standard deviation? 350 divided by the square root of 42. What's that? 60, 98. I don't know. All right, sorry. I'm trying to do this in my head. Can you guys just tell me what this piece is? Kind of makes sense to do that piece first. 980, give or take something. Jeff, you forgot what it was. I think I got like 98. Of course, I'm doing it in my head, so who knows? No, that's wrong, Jeff.
I got 88.84.
All right, thank you. Yeah, I made it too big because I went up and down. Okay, 88 point who? 24?
84.
84. Okay. Let me stop for a minute. Is everybody cool with that? Now let me identify a couple things before we do this. Well, actually, one thing is there is no plus and minus button in your calculator, correct? This means add that and subtract that. Okay. This is what we saw in our sample, correct? 980 is the test score, the average score of our sample. That's what that is. Give or take this. So this we call the error. That kind of makes sense. It's how far off from that we think the actual mean is. So now go ahead and do this. What's 980 minus this?
Wait, how do we put this in our calculator?
Sorry?
How do we put this in our calculator?
You do 980 minus this, and then you do 980 plus this.
Okay.
Yep. So this is really two separate statements written in a more concise form. Yeah.
Well, when I put the one before that, the 980 plus or minus 1.645, it just gave me a random number.
All right. So if you do that, did you get 1,000?
Oh yeah, I got 1,068. Then
Yeah, because you did 980 plus this.
yeah. Oh, and then I just subtract it.
It'll be easier to do this piece first, so you got less shit to subtract and add instead of putting
Okay,
this whole thing in twice. Does that make sense?
I see.
It's a good idea to figure out the error and then do the adding and subtracting. Okay, so what's this interval going to be then? I think it is, what did I say to myself? I say to myself, 891.16, is that right? When you do minus?
Yes.
And then when you do plus, it was whatever the hell you just said, 1,068.84. Sorry.
Yeah.
Okay. So what the hell? Have we done? All right. So here's what we have done. You're gonna really love this, right? And you know when a math teacher says that, you're like, shit. You're not done with the problem. You're not done with the confidence interval problem until you've written a conclusion. Yay! All right. So our conclusion here, I'm going to erase all this shit here. All right. I really want this to make sense. I know that 980, is everybody cool with the fact that 980 is probably wrong? Right? If I took 8 of you and I calculated your average age, do you think that's the real average age of everybody in this class?
No.
I would put a lot of money, and remember, I'm a teacher. I would put a lot of money on it being different. A lot of money on it being different, right? It's going to be freaking different. So what this does is it says, okay, I know you made this from a sample. So this is the adjustment. This is now saying, you ready for this? Here's what the conclusion is going to sound like. We are 90% confident that the interval, where do you go? 891.16 to 1068.84 contains the true mean SAT score for this little area in Kentucky. So, if I knew that the actual average for the entire United States, let's say the actual average for the whole United States was 880, right? We find out that the average for the entire United States is 880. What do you think our findings tell us about this region in Kentucky for some reason?
It is above the average.
Yeah, they somehow beat the average. For some reason, they do better. Now remember, do we actually know what the average is in this region in Kentucky? Do we know what the whole average is?
No.
No, because we had to build it on a sample. We don't have time to talk to everybody. We had to build it on a sample. But is this evidence that they do better than the entire US on average? Yes, that is evidence. Is it proof? No. There's a 10% chance I'm wrong. Do you see that? But that's better than normal for me, right? Only a 10% chance I'm wrong? Wow, it's amazing. All right. This is the kind of analysis you would do. Does anyone know the name Erin Brockovich?
Yes.
All right. What did she do? Do you know, Mara, what she was all about? What was she really known for?
They made a movie out of it, right? She was an assistant to a lawyer, and she was looking for she was pushing to look for research. There was something I don't remember, like something causing cancer in the area, right?
That's right.
It was the like contaminated water.
Yes. Do you remember who was contaminating the water?
Was it like a power plant, maybe? I don't remember.
PG&E. It was right here. So PG&E was contaminating water, but they didn't have evidence at first. So what they do? They had to go. Part of what they had to do, and I don't think this shows up in the movie, and I don't blame them because statistical analysis is kind of dry for a big movie. But part of what they had to do was show that the incidence of cancer.
Dang it.
You guys all right?
You will want to nap still.
Hold on. Let me mute somebody before they say something funky. All right. Let me start over. What was I saying? Oh, so you go to an area and you find the incidence of cancer and you show. So can you get the population? All right, I really want you guys to be with me on this. Has everybody got this? Let me erase this. Has everybody got this business? All right. Here it goes. If you go to a region, let's say that, I'm just going to make up some shit right now. I'm sorry. You just have to deal with it. Let's say that the incidence rate of cancer is 2% for the United States. And let's say I go to this region where there's been some complaints and I calculate the incidence rate of cancer there is anywhere from 3% to 5%. Is that evidence that something here is causing an yes, because 2% is not in here. So this is evidence, not proof, but it is evidence that something weird is happening here. What if we went there and I did an interval and I got 1.9 to 3.7? Is that evidence that something is wrong?
No,
No, because what could the actual average incidence rate be? It could be 2%. That is something within what I found, right? This one would be evidence that it's greater than 2% because the entire interval is above 2%. And why is it not proof? Because we're never 100% certain. Here's the thing. You guys ready? Here, let's do this. Let's look up a couple things. So we already know to be 90% confident, it's 1.645 is the z-score, right? Negative, positive. You with me? We already did that. Can you take a minute and figure out what it is for 95%? What are the two z-scores I'm working with? You remember how to do it. Let me help you out a little bit.
Is it 1.96?
Yes, it is. So let's make sure everybody can find that. What area would be down here if 95% is in there, 5% outside? There must be 2% there.
2.575.
No. You're getting ahead of me
Oh,
now.
oh, okay.
Your first answer was correct.
Okay.
Didn't say
I thought
what-
you need the other side, like you said.
Yeah, so 0.025, if you look that up, that will be negative 1.96. So this will be positive 1.96. Why does that make sense that it's bigger? What is, if I go up and down 1.645, how much data did I catch? You can do it. If I go up and down 1.645, how much data do I catch in a normal curve? Anybody? Come on, it's on the picture. It's right on the picture.
90%.
90%. I catch 90%. If I want to catch a higher percentage, should I have to go out further or not as far? If I want to catch more, should I have to go out further or not as far?
Further.
So it makes sense that if I want to catch 95%, I've got to go more up and down to catch more shit, right? Or more stuff, or more business, or more whatever have you. Okay. In fact, I hate fish. Not like I look at a fish and I go, I hate you. I don't like to eat fish, but I love the analogy of a fishing net. Should my net get bigger or smaller to catch a larger percentage of fish? It's got to get freaking bigger, of course. So I have to go further out to catch more shit. That's all it says. Now, here's the thing. What the hell am I talking? What the hell? What the hell, Jeff? If I want to have 100% certainty, if I want to be 100% confident, how far do I have to go? I just have to go to negative infinity and positive infinity. That's all. By the way, never do this. Never put infinity on a number line, but I'm just doing it for a quick visual. I can never be 100% confident because that would be stupid. It'd be like saying, somebody saying, let me take a guess how old that guy is. He's somewhere between 0 and 300 years old. It's like, good job, doofus. How does that help anybody? Does that make any sense? Anybody? Is that useful information? Yeah, that guy's somewhere between 0 feet tall and 80 feet tall. Well, thank you for that. That really helps narrow it down. Are you with me out there at all? Anybody? So I can never be using sample information. There is no way to be 100% certain about what the actual population is. Does that statement make, this is something we could have said on the first day of class, right? How in the world would I be 100% certain based on what I see about a little sample? Okay. All right. Let me see. So let's do this. Let's look at a handout that I have. Let's do this handout, and then I'll show you some real life examples of this, some stuff in the wild. So if you go on Canvas right now, let me pull it up here so you guys see where this is. Go to Canvas, go to Modules, go down to Chapter 7. Or no, Chapter 8, sorry. Oh, wait. All right, I guess I have to make it active. Let me make it active. Good job, Jeff. All right. Hold on, you won't see it yet. Activate. I'm gonna turn these stupid things off so they don't get all freaked out. All right. All right, now if you go to Canvas, I am sorry. You might have to refresh if you're already there. You'll see a section 8.1, 8.3 handout. Can you please go get that? So this is the example I was going to do earlier about dolphin lengths, and then I'm like, it's already on the handout. I got to think of something else. So pull that up. I'm going to open this a different way so it's easier for me to interact with. Why didn't you do this earlier, Jeff? Because I didn't. Leave me alone. Let's see, 160. What was this again? All right. Barf. There it is. What was that, Jeff? Was that baby sharks? Barf. Okay, here we go. I think that's the right thing. Okay. All right, so everybody got this bad boy? Okay. So don't worry. This other side is section 8.3. Don't look at that yet. It's going to get a little freaky. All right, we're going to do the first two parts of this together. All right, so we take a sample of 37 dolphins, and we find their average length to be 92.6 inches. We know that dolphin lengths are normally distributed with a population standard deviation of 4.11. So what could be happening here? Where am I? There I am. Stay with me. What could be happening here? And the way I kind of like to build this problem up is, let's say there's a little area. See, this is a little island. Let me help you out with my horrible drawing. Little island, and we take some dolphins from this little cove in the island, right? And we have a hypothesis. We're like, I think that the dolphins there have a better diet, and so they grow to be longer. You guys with me? So how do I test it? How would I, if that was my thought, if I'm like, okay, I know the food there's better, the water is cleaner than other areas. So I think the dolphins should have should be longer in length. They should grow longer because they have better conditions. How the hell would I test that hypothesis? What would I do? How would I start to see if that was true? What would I have to do first, obviously? Anybody? You're all like, it's obvious to you, math boy. I'm like, no, come on. If I want to show, or if I want to find out if these dolphins are longer than regular dolphins on average, what would I have to go do? No?
Get a sample.
Yeah. What would be the best thing to do? What would be the absolute best way to prove this was true? You could do it. Sample won't prove it, right? What would be the best way to prove it if I could somehow go and measure
The entire population.
the entire population of dolphins in this area, right? Do I probably have I don't know. You guys are like, who knows, Jeff? In this scenario, this is totally made up. Maybe you're some independently wealthy, crazy person, and you're going to go measure dolphins for the rest of your days. But more than likely, I don't have the resources to measure every dolphin. Are you guys with me? Maybe? All right. I can only see a few of you, and even you guys are barely saying it. Okay. Now, so I'm going to go. I'm going to take a sample of dolphins. I know that the sample average I get won't be the actual average. Is it possible that the sample I take just happens to be longer dolphins? Is that possible? That I just randomly happen to pick longer dolphins? Is that possible?
Yes.
Yes, totally, right? Couldn't you take a random group of people and just happen to pick taller people? Yes, that could happen. So I know I cannot base any evidence I'm trying to show somebody else just on a sample mean that I take, because I know it's going to be wrong. It's just as likely that they're shorter, but since I don't know, I can't use just that. So what this does is it creates a range in which we are such and so confident the real average sits. So that's kind of like stronger evidence for something. I really want you guys with me on this. So we do go down. We take a sample of 37 dolphins, right? Most of them are nice, right? A few of them are territorial and they kind of like come at you and they get you in the stomach. I'm sorry. I saw, what was it? Robin Williams he was so happy to be out with the dolphins. And then the first time he got in with the dolphins, one of them attacked him basically. And I was like, well, shit. Sorry. I can't get that out of my head. So we take 37 dolphins. So obviously what's 37? Why am I using this stupid thing? I'm going to have to delete everything I've done so far. Sorry. All right. Where's 37 go? What's that go in for?
N.
N. I love it. Gotta love N. It always means the same thing. The number of stuff I'm looking at. All right. What's the mean? What's the sample mean?
92.6.
92.6. I love it. And then the standard deviation we have. That's a population one. 4.11. I like it. Now here's a question I really didn't ask before. I don't think I did. Although I made sure this would work anyway. Let me see who's been paying attention. This is actually a chapter 7 kind of question. Why is it okay to use z-scores here?
The sample's more than 30.
Kick ass. Sorry, I'm just so happy. The sample's greater than 30, so I know it's normally distributed. Therefore, I can equate this area with a z-score. Now, didn't let me talk about myself in the third person. Didn't Jeff just help you find the z-score for 95%? Didn't we just do that? What was that?
0.025.
No, be careful. That's not the z-score. That was the area. What was the z-score we got?
1.96.
Yes. So this was 95. This was 0.025. So then we looked up the z-score. We got 1.96. By the way, I really want you guys, do you see the formula up here? The plus or minus piece? What does that have to do? How does that relate to the picture? This isn't a crazy question, right? What's the plus or minus piece? How does that relate to the picture?
It's our z-score.
True. So you have to start at the mean, you have to go.
You have to add it, then subtract it.
Yeah, you got to go up and down. Kick ass. So it's kind of nice. This formula has everything built in. So when you find the z-score, don't put a negative on it. That doesn't make any sense. The plus and minus are built in. All you care about is the number. It's 1.96. So now, do I have everything I need for the formula? Yes. I know the sample mean is 92.6, give or take 1.96 steps. Am I I recommend highly that you find the error piece first. Become a 1. All right, sorry. Rawr. All right. Oh, maybe I should do this too. Bum, bum, bum. So who's got the error? Somebody got the error figured out? Error.
32.
I think you said 1.32.
Yes.
Okay. Kind of a guideline for how much to round the error. Everybody ready? This is a note. You round it to 1 more decimal place than the mean. So this is perfect, 1.32, I love it. Everybody with me on that? So whatever the mean is, however many decimal points it's got, make the error have 1 more. So now who's got the interval that creates?
On our quiz, do you want us to do the multiplication part first and then, because I just put it all in the calculator. I don't know if you want me to show the 2 steps.
Yeah, and I want you to get used to doing the error by itself.
Okay.
Because I sometimes ask a question about the error, and the book definitely asks questions about the error.
Okay.
Does that make sense? So you could put this all in twice with a plus and a minus there, and you would get the interval, but you never calculated the error.
Right.
Yeah. All right, so who's got this? What do I get? 91 point something.
28.
28. I like it.
And
Up
then
to-
93.92.
I like it. So let's see if you guys, I know we've only done one of these. Can you finish this? So of course it's going to say, we are farmers. No, it's not going to say that. I only wrote this once, so maybe this is evil of me to do. So let's do this together. Maybe it's a little evil. We are 95%, oh, crappity doodah, hold on. Confident that the interval, now watch this. Don't just put 91.28. 91.28 what?
Percent? Inches?
Inches. All right. To 93.92 inches contains the true mean what of what? What's the problem about? In fact, you could just
Length of all dolphins.
true mean length of all dolphins. Let me put in here, since I changed it a little bit, all dolphins in that area, right? That little cove area. So if the length, if it's accepted that the average length of dolphins everywhere, just to make something up for a second, is 89 inches, is what we found evidence for our hypothesis. What was our hypothesis? We felt that the dolphins here would be, does anyone remember the thing I was talking about?
Bigger or
Thought they would be longer. We thought they'd be
Yeah.
bigger. Yeah. So if the actual average of dolphins everywhere is 89 inches long, is what we found evidence for our hypothesis. So there's a 95% chance that our interval catches the actual mean length of these dolphins, right? So it seems like there's a 95% chance that these dolphins are how related to all other dolphins. You don't like this question, okay. So here's the answer. Yes, it is evidence. It totally is evidence, right? Our interval goes from 91.28 to 93.92. So if somebody's like, well, every dolphin seems to have an average of 89. Oh, my dolphins in this area, I have found evidence that they are longer than that. Why is this not proof? Two things you can tell me. Why is this not proof? Why have we not proven that they are longer? Two things. I'll accept either thing. There are two things you can tell me, and I'll accept either one. Why is it not? Sorry.
Because you can't be 100% confident.
I love it. We're only 95% confident in that interval, right? What else? Somebody else give me an.
You only tested the sample?
I only took a sample. Kick ass. A sample is never going to prove shit about a population. You guys with me? Just go back to 2016 when they were taking samples of voters. Did the election turn out to be the same as the polls made it seem like it would be? No, it came out different. Yay! All right, sorry. I'll stop with the political commentary. But yeah, we can never prove something with a sample, but we can show good evidence of something with a sample. So this is sort of like a court case. We're sort of getting to the point where we're starting about how do we test a claim? Somebody makes a claim. How do we test it? Can we ever be 100% certain about their claim? Well, maybe sometimes, but normally we can't be, right? So we have to build in this like level of confidence in something. All right, so let me do this. Here, before we go to the second part of this, let's do this. We're going to do this live. I haven't looked at this ahead of time, so this could get, let's see how freaky this gets. What I like to do is I like to, in my free time, I like to, oh, that's interesting. Do you guys notice my emo bands? Look at my, anyway, sorry. If I type in your study.
Demon quotes.
Should I say again?
Demon quotes is what got me.
Oh yeah, yeah. Demon quotes. I was trying to come up with a joke about somebody whose nickname is Demon, but anyway. So study, if I type in the word study and I go to tools and let's say for the past week, I like to do this because it kind of gives me recent studies that have been done. That one sounds very dry. Let's see. NIH begin study. So it's not a completed study. So I don't want that one. Oh boy. Of course, there's going to be a lot of morbid stuff. Why wouldn't there be? USCF study shows mask ventilation stop COVID spread. Okay, let's see that one. It might even load. Oh, all right. So never ever stop at the stupid article about the findings. Go to the actual findings. All right. Now this is exciting for me, and you're all like, I don't know, Jeff. I don't know if this is going to show me what I want to show you. Let's see if this shows me. I'm going to look through this real quick. By the way, let's just talk about this a little bit. Hopefully everybody here is not an idiot, and you all know that masks stop the spread of COVID, right? And yes, I'm not going to pull my punches. If you think that they don't, you are an idiot. I just can't take it anymore. But what I'm looking for, I wanted to see if anybody left. That would have been funny if somebody left. Whoa, look at all this cool math. All right, this is not what I wanted, though. It's too bad, Jeff. They got some cool shit for later. All right. See, this is why I should have looked at all this cool math. All right, sorry. Oh man, Jeff, this is a lot of shit. Oh man, this is a lot of shit. Let's see if are they gonna give me anything? No. All right, stay with me, guys. Don't give up on me. I'm doing this live, and I should have looked at this earlier. Let's look at a different study because that one doesn't have what I want. Let's see. Vaccine effectiveness. Interesting. All right, you're gonna give me what I want, aren't you? Let's see. You can do it. You can do it. You can do it. You can do it. Almost. Where are you? You can do it. You can do it. You people. Here we go. Perfect. All right. Thank God. Oh, all right. Sorry. I'm excited now. So they all right. So real quick, now it kind of matters what the context is. So they're talking about vaccine effectiveness. Now that we got it out in the wild, they've actually seen that the effectiveness is higher than they originally thought it would be, which is nice. But one thing do you see anything in here that looks at all familiar? For example, let me draw your eye to right here. What do you think that stands for?
Confidence intervals.
Holy shit. So that's a 95% confidence interval. So most studies that you see, you will see confidence intervals for different things they've measured. So estimated adjusted vaccine effectiveness was 90%. The confidence interval went from 68 to 97%. Are you guys with me? So that is evidence that it's higher than 2/3, right? Which would be 67%. But it's kind of, do you guys understand that it's better than just saying 90%? If I give you this information, it immediately tells you more about how certain I am about the 90%. Were they very certain about the 98%? What would you say? Were they very certain about this 90%? Looking at the confidence interval. Is the confidence interval small or big?
Big?
Yes, it is big. If I ask the doctor, hey doc, how likely is it I'll survive the surgery? And the doc says anywhere from 68 to 97%, that's kind of a large range of percentages. Would you not agree? Wouldn't I want him to be able to say something more concise? So this is not saying that this study is invalid, but it is them being honest. If I give you a confidence interval, it gives you a better feel than just telling you one number. This tells me, okay, they know it's more than 50% for sure, but they don't know exactly if it's 90. It seems to be a wider possibility of range, right? Okay, I don't know if you guys are with me at all. Let's see if we can find one more study. Something that's not so insane. COVID vaccine safe for mom and baby. That sounds good. That's hopeful. That's nice. Do they link to the actual study? Yes, you always want to see if they link to the actual study. Oh, crap. Accept the cookies, sure. Give me your cookies. All right. You can see a bunch of N's. That's good. A bunch of N's. And look at what these are. What do you think those are? Oh, those are actually interquartile ranges. Somebody was asking about that earlier. So that's actually Q1 to Q3. This little bad boy, we're going to talk about in chapter 9, what the hell that is. So that's something to look forward to. Let's see if they actually give me any real confidence intervals. I don't think so. So they decided to go with the interquartile range instead. Anyway, all right, I'm sorry. I'll stop. I just wanted to show you some, what do you call it? Real life examples of what we're doing right now. So the work we're doing right now is kind of accepted, basic introductory work you would do with any of the variables you're working with in a statistical analysis. All right. God, I hope you all are still with me. Okay. All right. So let's do this. Let's go back to the sheet. Let's do the second problem, and then we got to talk about the math behind the third problem. So we just created a 95% confidence interval up here, right? Do you think that the 90% interval would be smaller or larger than the 95%? Would it be wider or not as wide if I make a 90% confidence interval versus 95?
Smaller.
Smaller. It's got to be smaller because it has to catch 5% less stuff, right? So what's going to change here? The only thing that's going to change, so I'm still going to have the same average that I found for my dolphins. I'm still going to have the same population. I'm still going to have the same 37.
Is our z-score the only one changing?
Yeah. The only thing that changes is the z-score. And who remembers what the z-score was? We did that one earlier for 90%.
1.645.
Yeah, so z is 1.645. So then if I throw everything in the formula, 92.6, give or take, 1.645 of these. So now I should get a slightly narrower interval at the end. Somebody have the error? The error? Anybody? The error? You guys have the error?
I got 1.11.
Kick ass. That's what I got. So either we're both right or we're both wrong. So I get 91.49. Sorry. Up to 93.71. Which is definitely narrower than this one was. Right? It's more narrow. So is that better then? Is this confidence interval better? What do you think? Is this confidence interval better than that one? How confident are you about this interval? I could
90%.
90%. I was going to say I could read your mind. You're all like, I'm 0% confident. Okay, math boy. I have no idea what's going on. If that's true, you got to ask questions, please, dear God. But we're 90% confident in this interval. We're 95% confident in this interval, right? So there's a bit of give and take. This, you might say this is better because it's not as wide. It's more specific, but you're losing confidence in what this says. This one, you're higher confidence, but it's wider. So there's give and take there, right? And I love it. Again, stats is the most honest math. It says you want to be 100% sure, too damn bad, right? I love that shit. Right? Algebra is all like X is 7 for certain. You're like, all right, algebra. Statistics is like, I don't know. Which I love. It's more like real life. Anyway, sorry. So if I want to do my little, we are, oh my God, Jeff, what language? Dude. All right. I am not drunk. We are 90% confident that the interval 91.49 inches to 93.71 inches contains the true mean length of dolphins in this area. All right, blah, 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 blah. All right, I'm tired of writing. Basically the same thing up here. We just put the 90 and we put the other interval and we're good to go, right? Now, let me do something on the board I want to do something to explain this idea better. I'm going to stop sharing here. Ready? Here it goes. We're stop sharing. Bye. Okay. I really want you to understand. I don't know if you're just grudgingly accepting the conclusion you're going to have to write. I really want to make sure you understand why I am writing it the way I am. So here we go. So before we travel down to this island, before we go down to the island, was there a true mean length of the dolphins? Was there an actual average length of the dolphins? Does it exist? Is there an average length of all the dolphins in that area? I don't know. Is this a weird question? Before I go down there, is there an average length of the dolphins in that area?
Yes.
Yes.
Yes, there is. There is. So here it is. It's right there. There it is. When I go down there, or us, we all go down there, right? This is not going to happen. I'm sorry. Too bad for you. In our minds, we take a trip down to this beautiful cove off this island, and we're measuring dolphins, which is amazing. I find a sample mean. More than likely, it won't be equal to this, correct? So maybe our sample mean, let's put a little bar here. So here's where the true mean is. Maybe our sample mean is here, correct? Maybe. You with me? We just happen to pick some shorter dolphins, right? So what we do when we make a confidence interval, we go up and down. Do you see what just happened? Did this interval catch the real mean based on what I drew?
Yes.
It totally did. I love it. Now, a different team of researchers, we leave, and a different team of researchers comes around the corner, and they come out there, and when they take a sample of dolphins, will they happen to take the same sample we did? What do you think? Would you put money on them picking a different sample?
Yes.
Of course. More than likely, if they go take a random sample of dolphins, theirs is going to be different. So let's say that they get an average here, right? And when they make their interval, they get that interval. Did their interval catch the real mean?
No.
No. Now let's say 98 more research teams go here. I have no idea why knowing the length of dolphins in this area has become important, but give this year some time. It doesn't sound so weird anymore. In a month, we might all be talking about the length of dolphins around the cove in this island. Why not? Weirder shit has happened. But 98 more teams go there. What does it mean to create a 95% confidence interval? It means that 95% of all the confidence intervals that can be made will contain the real mean. Let me say that again. When you make a 95% confidence interval, that actually doesn't mean anything specific about your interval, to be really honest. It means 95% of all the intervals that could be made would contain the real mean. So how many total teams went out there? 100 total. How many would I expect to have an interval that actually captures this? 95 of them, if they all make a 95% confidence interval. So you have to say we are 95% confident that our interval, blah, 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 to blah, 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 captures the mean. You cannot say we are 95% confident that the real mean falls in our interval, because it doesn't fall anywhere. It's been sitting there before we even came, right? It existed before we came. So we have to word our conclusion as if we threw a net out, and we're 95% confident that the net we threw out caught the fish. So it's 5% of the time, somebody's going to throw the net out and it's not going to catch that certain thing. All right, I have no idea how you guys feel about any of this. All right. So that time I tried something new. I told you a little more concept after we did the concrete stuff, just to see how you would feel about it. So you're all like, I don't know, Jeff. All right, so let's do this. Here's some exciting stuff. You ready for some exciting stuff? You're all like, what's exciting to you, Jeff? What's exciting to me is some algebra. So what is the, well, here, let me write the formula down. What part of this formula is the error?
The part after the plus or minus.
Good. So this part. So I got Z sigma over square root of it. So let me write this as E equals Z sigma over the square root of it. Is everybody with me? Solve that for n. Algebra. 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 It's algebra. Bruh. All right. What kind of sucks about trying to solve for n? Why is n like the worst letter in this whole thing?
It's square rooted.
And
It's on the, it's the denominator.
Phenomena. That's right. So it double sucks. So can somebody tell me what algebraic maneuver would you do to get this started to try to solve for n? What would you do first?
Multiply with n.
Multiply by what?
N.
No, that won't help. I think I know what you're trying to do, but. So what if I multiply both sides by the square root of it? Right, how does that help? Why does that make things better? Because now at least the n is not on the bottom. Everybody with me? You guys okay out there? No? Okay, I understand. Then I can divide by e, right? Maybe I'm doing too much at once, but we'll see. So now I got square root of n equals z sigma over e. Notice something. Do you guys, real quick, side note, I really want you. What is 10 divided by 5?
2.
2. What is 10 divided by 2?
5.
5. Holy shit. So what did the 5 and the 2 do? What can they do legally? They can switch. Right? So I could actually just switch the e and the square root of n. They switched. Do you see how they just switched? All right. Yeah, sorry. That's a beautiful little tiny thing to learn from algebra, is when you have your variable on the bottom on one side, you can just switch the shit up. Because of course something divided by a chunk equals the other chunk. Sorry. And the last thing I have to do here is
circle the answer.
no, because do I have n by itself yet?
Square both sides.
Square both sides. I like it. I see you in the chat. You're right. All right. So now if you look back at the handout, are you ever going to have to do this yourself? No. Do you even have to write this down? No. Because now it's just a formula I could use. So what the shit does that formula mean, Jeff? All right, so here's the idea of this formula. You ready? I already know. Now, let me see if you guys are with me on this. To get an error of 1.11. Oh, wait, I'm at 95%. Oh, this is such an evil handout, Jeff. So I went back to 95% confidence. You guys see that? So up here is my 95% confidence. To get an error of 1.32, how big of a sample do I need? 37. Does it make sense that if I want my error to be smaller, well, let me ask you this instead. If I want my error to be smaller, should I have to take more or less of a sample to make my error smaller? What makes sense? Should I have to take
More?
say again?
Did you say more?
More. I'd have to take, does that make sense? To make my error smaller. How do you get more certain about something in statistics? Do you take a bigger sample or a smaller sample to be more certain?
Bigger sample.
Bigger sample. So this formula says, all right, if you know what you want your error to be, you can actually figure out backwards. You can figure out what sample size you're going to need. Because the bigger my sample gets, the smaller my error should get. Does that make sense? We've known that since day one, right? How do you be more certain about what you find in your sample? Is you pick a bigger sample. So what is the error going to be on part C? Jeff, what are you doing, buddy? All right. What's your error going to be here? What do you guys think? Read through that statement in part C. What part of that is the error?
Ninety-five percent.
Yeah. See this word within? See how I bolded it and underlined it? As if I was being nice for a moment. That word within is not the only word they're ever going to use, but it is one of the key words that tells you that's the error. That's what error means. I'm off by that much. I'm within that much, right? Okay. So error is 0.5. Jeff, what is all that? 95% confidence, we figured out the z-score was 1.96. Is that cool? We saw that up here. Weehaw. All right. Shit. We also know from the beginning that sigma was 4.11. Is that right? Yes. So are you with me? So I told you at the beginning sigma's 4.11. We know the z-score is 1.96. And this told me the error wants to be half an inch. So up here, we had 1.32 inch error with 37 dolphins. So now I'm saying, well, how many dolphins would I have to get to be within half an inch? Well, I don't know yet. We got to figure it out. So let's throw all this shit in here. 1.96 squared times 4.11 squared divided by 0.5 squared. Now, to be honest, you could actually put it in your calculator like this. 1.96 times 4.11 divided by 0.5, whole thing squared. Both formulas are the same. Right, the second way is like the formula we have up on the board. All right, so hopefully that all makes sense. It's just less typing for the second way to do it. All right. So what do you guys get when you throw that in the old calculator?
I got the same as Corbin, 259.57.
Oh no, is somebody chatting at me? I can't handle it. Oh, there we go.
Got the same thing too.
All right. So 259.57. And here's, oh shit, Jeff. There we go. Here's what we always do. Let's see if this makes sense. If that is this is how many I need to be within half an inch. No matter what this number is. Can I get 259.57 dolphins?
No.
Please don't do that. Don't be the Dexter of dolphins. Don't go out there and start chopping these poor things up, right? What we do is we always round up. So 260. So it only took 37 dolphins to be within 1.32 inches. If I wanted to know within half an inch, I'd have to take 260 dolphins. Does that make sense? This is what I call a feasibility study, right? We go 260 dolphins. Can we handle that? Do you want to do that? You know, and then we figure out if we want to do it. If we can't do that, then we have to live with a worse error. Does that make any sense? So I can figure out ahead of time how big of a sample I should take, which is kind of nice. Depending on how close I want to be, how little I want my error to be. Okay. Now this is all very new. We just got into this today, so give yourself some time to absorb it. I think that's all we're going to do today. I like to do chapter 8 out of order. So the next thing we're going to do is section 8.3, because section 8.1 and 8.3 use the z-score chart. Section 8.2, we get a different chart. Oh, good. Fantastic, Jeff. I love that. Will that be the last chart we get for the semester? No, there's going to be one more chart after that. Oh, shut up, Jeff. That's not funny. Oh, that's too bad. All right, guys. That's enough for today. What do you guys think? Is that all right? Is that enough? You want more?
I have a question.
Yes.
For the first one, the number 1, how did you get the 89?
89. Where's 80? Oh, here. Oh, no. I'm sorry. So again, this was me just adding on to the problem. I said, what if the actual average was 89? Would this be evidence that the dolphins in this area were longer? Yes, it would be evidence because the whole interval is above 89. So that's kind of like that next step. Once you create a confidence interval, what could you use it for? You could see if it's evidence for something. Yeah. Anybody else? You guys okay out there? You guys love stats so much you don't want to leave? I could do more. Today is a weird. So you guys can leave unless you have a. Yes, I will be posting the answers for the practice quiz 5 sometime by this weekend. I just want to give you guys a time to work on it yourselves.
Thank you. Have a nice weekend.
You too.
Bye. Thank you.
See you.
I think we wanted to set up a study group.
Oh, all right.
But I think everyone is leaving now. So
Yeah, I can still email everybody. So I can set one up tonight or when?
Yes.
So yeah, I can set one up for tonight and just send an email out and see who shows up.
Okay.
Yeah, so let me do that right now before I forget.
Thank
Everybody
you.
else okay? Sure.
Yes. Thank you.
Sure.